binomials. When a binomial has, yeah, how about you pass those back? When a binomial has subtraction, okay, so binomial means it has what?
Subtraction.
Two,
Or
binomial means it has two terms. If there's subtraction between those two terms, and both terms are perfect squares, we look at it and we say, oh, you are the difference of two squares. And that makes me happy because you're easy to factor then. So examples. Do you agree that x squared minus 9 would be the difference of two squares? What's the rule? Is it a binomial? X squared minus 9. Is it binomial? Yes. Is there subtraction?
Yes.
Yes. Is x squared a perfect square? Is 9 a perfect square?
Yes.
Oh, cool. It's the difference of two squares. How about 4x squared minus 25? Yes or no? All in favor of yes, it's a difference of two squares. Oh, popular. All in favor of it not being? Well, Jay, what are you, a maybe?
I was the only one.
I wonder what answer that is. That's a, so even while you're long, okay, so how about you write down one now? There's a blank space there. You write down a perfect difference of two squares. Go ahead, here. You can do it. Write down one that you believe is the difference of two squares on your notes.
I use any number.
Huh?
I use any number.
You get to do whatever you want as long as it's the difference of two squares. And if you're really stuck and you're like, I can't get any, I bet there's a few hanging out over there on the board. Alright? Okay, give me some examples of what you wrote there. Patience, what do you have?
49x squared minus 25.
49x squared minus 25 works. I like that one. Give me another one. John?
16x squared minus 64.
16x squared minus 64. I like that one. That one works. Let me hear one more.
X squared minus 4.
X squared minus 4 works. Okay, so what you had to do is you had to come up with something that was a perfect square in the beginning, something that was a perfect square at the end, and put subtraction between it. How do we get perfect squares? How do you get perfect squares?
I totally forgot.
You take something
times
times itself. Okay, so tell me, do you think I'm gonna have one here for you? 81x to the
11.
oh, I think I'll make it the 6th power minus 144. Is that the difference of two squares?
Yes.
Is there anything that you could take times itself that would give you 81x to the 6th?
No. Oh, yeah, yeah. Yes.
9x.
9x.
9x to the 3rd. I got a perfect square. How about 144?
12.
12. Oh, mine qualifies, doesn't it? Okay, so here's how the shortcut we're going to take. It's going to be so easy to do this. To factor them, find the square root of both terms. Find the square root of both terms. Because that's what each factor will begin with. So each factor will begin with the square root of the first term, whichever one's first, in the difference of two squares. The square root of the first term will be the first term of the binomial factors. And those binomial factors are going to end with the square root of the second term, the second square. Well, and just like happened up here, one factor will have addition, and the other factor will have subtraction. That's the only way to get a binomial answer when the first term and the second term of the binomials match, and we want that over step to cancel out. Okay, so x squared minus 9. Here's how we show work. Square root of x squared is
X.
x. Square root of 9 is
3.
3. Both terms start with x, because that was our first term. It's square root. Both factors, I think I might have said that wrong. Both factors start with x. Both factors end with
3.
3. One has
Addition.
addition and the other has
Subtraction.
subtraction. It's pretty painless. Okay, we do the next one. Show the work.
So bad, I'll beat you again.
Did you?
I'll be quicker than that.
You're right, Beth. Okay, notice that was when A was equal to 1. They both started with x, right? What if A isn't equal to 1? Well, they both start with x? No. You have to find the square root of the A and the x squared. So the square root of 4x squared is
2x.
2x. The square root of 25 is
5.
5. 2x, subtract 5, 2x plus 5. Does it matter? Can I do it that order?
Yeah.
Yes.
Sure.
It's funny because I did it that way before you said it.
Okay, do that fourth one now again on your own. See if you can agree with Daylon because he's faster than me. Daylon, what's the answer? Oh, I might beat you this time.
Oh, you choose 3x plus 4 and 3x minus 4.
Okay. So what should happen when we multiply those out? To take you back to that binomial that we factored, right? So they're pretty easy to factor if they are the difference of two squares. So the first question you always have to ask yourself is it a square? Or once you start trying to take a square root, you're going to be like, oh, can I? Okay, let's go to the back side. What if it's 1 minus 36x squared? Should I change that to add the opposite? No, we didn't in the front, did we? We're just going to say, oh, the first term is 1, not 36x squared. It's 1. And the second term is 36x squared. And the square root of 1 is 1. And the square root of 36x squared is 6x. We don't do anything with negatives here. We just find square root of 36x squared. And now we set up our 1 plus 6x, 1 minus 6x. Notice that's like the third one in each column over here on the board. They started with a constant, and their second term was the variable term. And notice how the answers ended up, it's just like how ours started up there, a constant minus a variable term. Okay? Okay, do number 6 on your own. You got this? And the answer is, the table over here thinks it's not factorable.
I agree with that.
You agree with that?
I'm agreeing with that.
6 isn't a perfect square, but x squared is. But 6 has got to be 2, doesn't it? Yeah. So we're going to say, hey, wait a minute. Once I did this, I said to myself, can't do that. I can't get the square root of 6, and it's a nice integer value. So I'm going to say it is not factorable. And I can show this as my reason why. I tried to take the square root of 6x squared and guess what? Couldn't do it. It's very tempting to think that it's 3x, isn't it? I bet some of you thought it was. Is 3 times 3 6? No. 3 plus 3 is 6 though, isn't it? Okay, so sometimes they're not factorable. Even though it's binomial, it's got subtraction. You see that x squared there and you're like, bingo, I can do this one, it's the difference of two squares. And sure enough, in the answer bank, in a multiple choice answer bank, guess what they would have? 3x plus 7, 3x minus 7. And you'd be like, got it. And that's what would happen, it happens all the time. Okay, now I say, don't be fooled into thinking you can do the same thing with the sum of squares. What does sum mean? Addition, you added something together. Okay, so sum of two squares. And I give an example here, I say x squared plus 4. You might think you can factor this. You might say, you know what? Oh, well we learned just a little while ago that you just do this. It's just this easy. I don't have to even hardly think. I can just say the square root of x squared is x and the square root of 4 is 2 and I'll put addition in one and subtraction in the other and I'll have my answer. What does this yield? We already know. What does this yield?
But if you sum it, it would be.
What if we multiply this out?
Minus 4.
That would be x squared subtract 4. Same thing? No? Okay. Well, then you might say, okay, well then here's the typical one. People say, it's this. Hey, Mrs. Grant, I already know it's x plus 2 times x plus 2. Would you FOIL that out and see if it is?
No, I go to x plus 4, x plus
Go
4.
ahead, just FOIL it out and see what happens.
I already did it.
Okay? I get a trinomial. Do you get that trinomial too? Is that the same thing? No, that's not another name for x squared plus 4. Well, then you're like, okay, fine, LeGrand. I'm going to show you it's x minus 2 times x minus 2.
You get another trinomial.
And what's going to happen?
You get x squared minus 4x minus 4.
Minus 4?
Oh, plus 4.
These guys come together and we get x squared minus 4x plus 4. And you're going to try and convince me that that's x squared plus 4. Good luck. So what are we going to say? Is x squared plus 4 factorable?
Yes.
Is there a GCF? No, it's not factorable. The answer is a big, fat no. Don't even try. But trust me, students try all the time. Even upper level math students try every time. They see x squared plus 9 and they say, oh, that's x plus 3 times itself. Because the square root of x squared is x and the square root of 9 is 3 and there's addition in it, so I'll just put addition in both of my factors. So we say this is not factorable. Okay. Okay. It is time to go to work on your homework.